Good morning. I'm Dave Stevens, the Chief Technology Officer for Brocade, and I want to just echo what some of the others have said. And thank you for coming to today into the campus and spending time with us today. I think energy efficiency, in particular, is an incredibly timely and relevant topic, and it's one that we hear from our customers all the time, and it's an imperative to get done because, as Mike said, we're running out of capacity in many of the data centers. I'm going to try and spend about 30 minutes this morning. I'd like to take just a couple of minutes and give you a little bit more background on Brocade for those of you that are not familiar with the company, and try and talk a little bit about why we're so relevant in the data center. As Mike said, we're about a 15-year-old company, and we were really born and started in the data center. So it's really appropriate that we host this summit along with the Silicon Valley Leadership Group, and we have very good visibility in the customers as to what's going on with the transformation of the data centers that are happening. I'll spend a little bit of time talking about trends in the data center, a little bit more from a compute and networking perspective, and what kind of implications those have in data center design, and particularly the energy and power and cooling requirements that show up in data centers as a result of those transitions. And then, as Mike said, we've recently moved into this campus over the last, the design started, I think, about 3 years ago. We started moving in March, and I'll, in the true, case study format, I'd like to share some of the facts and figures and lessons learned around that move, and some of the things that we're able to accomplish in moving over into this campus facility. So as Mike talked about Brocade, again, he mentioned this, about a 15-year-old company. It was actually 3 guys and a woman and a keg of beer and a card table, but started here about 15 years ago in Silicon Valley in what Carl always calls the innovation economy. We are a true product of that. And the focus of that early group was really around solving a storage networking problem in the data center. The team was really looking at the ability to take these large storage farms that were being built in data center and very, very efficiently allocate that storage technology into the compute systems that were being deployed in the data center and share that storage capacity across those compute systems. And that early innovation became what is today the fiber channel networking industry. Out of that team is where that came from. Today we're about 4,600 employees, all majority of which are headquartered here. As Mike said, we've added about 500 employees, I think, over the last year. And we operate in about 160 countries around the world, running just about $2 billion annually in revenue, a lot of that outside of the U.S. So we've turned from a startup and the 4 people on the card table into a reasonably sized multinational corporation that's having tremendous success. The product portfolio, I won't take you through all the stuff that's in here, but we continue to support the early storage networking products that the company was founded on, but that portfolio has expanded very, very significantly over the years to today having embedded switching systems in blade centers. We make those for HP, for IBM, for Dell, for Fujitsu, people like that, and as well as very high performance Ethernet networking products and routing products that show up in the cores of data centers and internet exchange points around the world. So really a very broad portfolio of products, as Mike said, centered around high-performance networking technology deployed in service providers and enterprise networks around the world. Probably because of where the company was started in the storage networking business, our customers tend to be and tend to have some of the largest and toughest environments in the world. We're in probably 90% of the Fortune 1000 data centers around the world, where we provide both Ethernet networking capability and storage networking capability. We're in 80% of the world's busiest internet exchange points around the world. The growth in internet traffic that Casey talked about and that Mike talked about is happening in very dramatic fashion. As an example, one of the customers that we have in Europe is currently in one of their internet exchange points, currently transiting just under 1 trillion bits per second through that exchange point. And they'll pass that mark in probably March of next year. They're at 950 gigabits sustained, 24 hours a day, 100% of the time through that exchange point. And that's one of dozens of exchange points around the world. So we are seeing very, very dramatic growth in there. And then, of course, we build products for networking, campus like this one. This campus has about 10,000 end-user-facing gigabit Ethernet ports where we run data systems, we run our video surveillance, we run our phone system on it, we run temperature, proximity sensors, the building management system runs on it, the security systems on the doors run on it. Really everything in this building runs on that network infrastructure, and that's being repeated for customers around the world. Very simply, our strategy for continuing to grow the company is relentless innovation. We spend about 20% of total revenue every year on research and development. We've spent more than $300 million in interoperability facilities that many of you will tour over in Building 1 later this morning. And we spent northwards of $1 billion in cooperative research and development with some of the largest data center infrastructure providers in the world: HP, EMC, IBM, Sun, now Oracle, Network Appliance, folks like that. And probably one of the most critical things is the people. And so it was a big focus in building the campus, making it comfortable, making it good for the employee base. So as you wander around the campus, you'll see an awful lot of focus on the employees. We continue to try and attract and retain the top talent really worldwide from the networking industry. And we're having tremendous success at doing that. As I said, we added about 500 people last year. And we were recognized over the last year as one of the top companies to work for by Fortune magazine, as well as the San Francisco Business Times. So that's a little bit of a snapshot about Brocade. So let's talk about some of the changes that are happening in the broader networking industry. For probably the first time in maybe 10 years, the networking industry is undergoing really dramatic change, and data centers are downstream of that and seeing the same levels of dramatic change. And it's really being driven by some external factors that I think we can see every day, but continue to happen. The first of these is really the number of devices and the complexity of devices that we're starting to add onto the network. If you look at what we're adding onto the network, we've gone from sort of pagers and voice-only cell phones to devices which are capable of sourcing and consuming really a lot of information. This is video cameras, iPads, iPhones, Android phones, set-top boxes, streaming media like Netflix to your TVs. And by some estimates, we'll get to about 15 billion devices attached to the network by 2015. So that's a lot of devices. At the other end of that wire, and what's showing up in the data centers that we're all working in, is an enormous growth in the amount of persistently stored information that's being put in the data centers. And so even through the downturn in sort of 2008 and 2009, we saw growth around 70 or 80% in the amount of persistently stored information in data centers. And in between those two things is network infrastructure. And over the next decade, companies like ourselves and other companies here in the Valley will spend a huge amount of money upgrading that network infrastructure between those two endpoints. Host virtualization, like VMware, KVM, Xen, Hyper-V for Microsoft, are adding a real wrinkle into that equation because they're allowing virtual containers to be put around applications. And that has dramatic implications for data centers because what happens is the applications are now mobile. So one day they show up in one data center, the next day they show up in a data center, in a different data center that's maybe across town or across the world. And so the effect of that is that the load within the data centers can rise very dramatically and very quickly, and a month later the load can disappear and show up in another data center in another part of the world. And virtualization is allowing mobility of those applications and allowing very, very rapid deployment of the applications and movement of those. And then cloud computing is really a result of the drop in the cost of bandwidth. It's now actually cost effective to host an application here in our data center, take the same application, move it to Colorado. Our employees here can't really tell the difference. Cloud computing is really all about placing applications where it really makes business sense. There's an interesting phenomenon I think that we don't always see when we look inside the data centers, and that is that while we're building larger consolidated data centers and denser data centers are actually expanding, or I would make the case that they're actually expanding. If you look inside the data center, systems used to be very closely contained, and then went to mini computers, which were a little more distributed. We went to client-server computing, web-based computing. With the proliferation of these very smart devices outside of the data center, there's actually now 4 times more data stored outside of data centers than in on the devices that are out there. And there's about 10 times the compute capacity and I/O capacity on the endpoint devices than there is an end. And this is having the effect of taking the data center requirements, what we do today in relatively constrained spaces, and starting to stretch those out all across the network infrastructure. So the requirement for nonstop operation, for hardened networks, for wiring closets that begin to look like and take on the characteristics of little mini data centers are starting to actually expand across the world. Cloud computing has been a really a term that's been bandied about quite a bit over the last years, and by some simple definitions, cloud computing is really all about any application that's hosted in a location outside of my enterprise. So Salesforce.com is a great example. RingCentral, which is an outsourced phone system, Gmail, Hotmail, Yahoo Mail, Google Apps, all those kinds of applications where I host them remotely are what cloud computing is all about. But the adoption of cloud computing, if you find any of our customers that are here that are hosting providers, Todd Benjamin is here, I think, from Hostway. Ask him about his data center, and what he'll tell you is, because applications are being hosted out there and because it's very difficult to predict the demand, the implications on his data center are that he has to very rapidly be able to scale it up and scale it down because he doesn't really know what the demand is going to look like. So nobody's going to call him up in advance and say, hey, I'm going to send you an order next week and I want 1,000 servers online. They're just going to show up at his doorstep and tell him they want them online. And he has to be prepared to scale that infrastructure up very, very rapidly. And then when that demand goes down, to take that infrastructure and put it away. He can't build to compete capacity because he can't stand business that way. And so the implications on data centers is that we have to make them very, very flexible. We have to be able to make them larger, make them smaller, and be able to do that on demand. Now, enterprise data center managers look at that and they say, hey, that looks like a pretty good way to run a business. So software-driven infrastructure, I'm going to do the same thing. And so we're seeing these same sorts of cloud paradigms appear in internal data centers where virtualization technology, networking technology, storage networking technology are all being combined to give us the ability to very rapidly scale up the infrastructure and scale it back down as the demand changes. And that rapid change in the infrastructure has very, very profound impact on how we build data centers, how we provision for power, how we provision for cooling. So one of the things you'll see in our data center here, if you are fortunate to go tour through this, is we can very rapidly reconfigure the data center. We can go from a kilowatt per rack or 2 kilowatts per rack to 8 kilowatts per rack in a matter of 2 or 3 days, and reconfigure cooling, reconfigure space, and that's becoming a requirement for many of the systems as we build out the data centers that are here, getting to this idea of fully virtualized data centers. So if you look at a snapshot in time about how our customers have been going through this, this is a model that we use to track how customers are going through this. And historically, over the last decade, we have built data centers, for lack of a better term, by replicating components. We've had a model when x86 servers were very inexpensive. We had this model that said, take an application, put it on the compute node, connect it up to an appropriately sized network for storage and for data, and just repeat that process until you run out of applications or run out of space or both. And the result of that, when we walk into customers that have built data centers like this over the last decade, is that the average server utilization, and this is an IDC figure, runs around 15%. So servers are sitting there 15%, 85% of the time they're effectively idle, except sucking down power and cooling resources and generating heat. And those enterprises are spending roughly 70% of their total budgets to just keep that running. And as the requirements go up, as the information requirements go up, this is very clearly not a sustainable model for everybody. All of our customers know that they can't continue to go down this path. So the reaction to this has been the very rapid adoption of virtualization technology.